Okay, we're going to start part 2 here. We're going to look at a square. Now, we're going to start again by graphing, and in this case you can make up your own 4 points. I'm going to choose some easy points. Now think about, for a square, you know that the sides are all congruent and the angles are all congruent. Okay, so I'm going to do this. I'm going to choose negative 4, 4. I'm going to choose 4, comma 4. I'm going to choose 4, negative 4, and negative 4, negative 4. All right, there's A, B, C, D, and I'm going to connect them. Now again, you can choose any points that you want. These are the ones that I've got, and that's going to give us a square. Now again, a square is a parallelogram, so the opposite sides are parallel, both pairs. The opposite sides are congruent, but in this case, all the sides are congruent, just like a rhombus. The opposite angles are congruent, but in this case, all of them are congruent. They're all 90, just like a rectangle. Okay, a square is, you take a rhombus and you take a rectangle and you put them together, and what you get is a square. Okay, now let's draw the diagonals just like we did for the rhombus. So we'll draw AC, and then we'll draw BD or DB. Now if you had to guess, what do you think is special about the diagonals? Well, if it's like a rectangle, then what's going to happen if you measure this? Let's just measure it here. The length of AC is about 5 centimeters from me, and the length of DB is about the same. So it looks like they're congruent, and that makes sense because if it's a rectangle, a square is a rectangle, the diagonals are congruent. Okay, so there's one thing that we know. They bisect, which means all these pieces are going to be congruent. Now because it's also a rhombus, it's like a rhombus, so the diagonals of a square, they're congruent, but they're also perpendicular. We're going to say perpendicular bisectors. That means they have 90 degrees at the center. These are all 90s. And also angle bisectors. So if it's a rectangle, diagonals are congruent. If it's a rhombus, diagonals are perpendicular bisectors and angle bisectors. If it's a square, all three. You've got all these. Okay? Now, the other thing about a square is that if the diagonals bisect the angles, if you bisect the 90, well then you know that each piece is 45 degrees. So all of these are 45s. Now, we're not going to go through all the formulas like we did with the rhombus, but you would find that the slopes of the diagonals are opposite reciprocals. That means they're perpendicular. That's where you get perpendicular. The midpoints are equal. That's how you get the bisecting. And then the diagonals are equal. That's how you get congruent. Okay, so if you want to check that, that's what you're going to find. Okay, so let's do a couple examples here. Number 2. Just like number 1, go ahead and try to do this yourself, and then turn the video back on and let's see if we agree. If you want to start with x this time, 5x degrees is here. It's an angle. You know that the angles are perpendicular, so that's 90. So one equation, we have 5x equals 90. Divide by 5, x is 18. Okay, now the y. Let's go for y. 3y degrees. This is an angle right there. Now, you know that in a square you have right angles, but also the diagonals bisect the angles. So this has to be 45 degrees. Now, 45 is not the answer. 3y equals 45. So we divide by 3, and y is 15. Now the last piece here, we need z. For z, this is a segment. There's no angle measure there. And we know that the sides of the square, all four sides, are congruent. So we can say 4z equals 30 minus 2z. Now let's see, to solve this, we need to get z on the same side. Let's go plus 2z plus 2z. So we get 6z is 30. We'll divide by 6. Oh, so I'm running off the page here. So we get z equals 5. And that's it. Now the last one here, quadrilateral WXYZ. So they give you the points, and then they say, what is the best name for this quadrilateral? Is it a parallelogram, rectangle, rhombus, or square? Well, the best way to start this, let's graph it. There's W, X is 1, negative 1, Y is 3, 3, and then Z is 1, 4. Now if you look at this, you can probably guess what the answer is going to be. But we don't want to guess, we want to know. When I look at this, I think it's either a parallelogram or it's a rectangle. Now if it's a rectangle, that means all the angles have to be 90. And if the angle measures are 90, that means the sides are all perpendicular. So let's look at the sides, let's count slope. Let's do the slope of WZ. Okay? So I'm going to count this. I'm going to rise 1, 2, 3, 4, and then I'm going to run 2. So 4 divided by 2, okay, that's just 2 over 1. Now how about the opposite side, XY? 1, 2, 3, 4, run 2. So those are equal. Okay. Now how about the bottom? How about WX? The slope of WX, I'm going to go down 1, which is negative, and then right 2, which is positive. Whoops, down 1 and right 2, negative 1/2. And then ZY is going to be the same. Now if you look at your slopes, 2 over 1, negative 1 over 2, those are opposite reciprocals. Well, let me point it out over here. 2 over 1, negative 1 over 2, those are opposite reciprocals. That means that all these sides are perpendicular. That means these are 90. Now, it's a rectangle. Is it a square? Well, if it's a square, then that means all four sides are also congruent. Now, if you look at this, you can see right away that the top and the bottom, they're not the same distance as WZ and XY. Okay, so it's not a square, and we're going to say it is a rectangle. And that's our answer. Okay, and that is the end of the notes.